Before further proceeding towards this question, I will suggest you to watch the beam design part 2 because the whole design procedure will be followed in this video will contain the concept that has been given in the previous video of design of beam part 2. Now this question I will initially tell you the importance of this question. This is the question taken from a past paper of SPSC paper 2018, concrete technology and structure design question number 6. This is the question that has been taken from a past paper of SPSC paper 2018 of concrete technology, question number 6. So we will solve this question according to the design procedure has been explained in the previous video, design of beam part 2. Now before getting to all those steps of design, we initially need few data we have to get from these statement to further design this question. Initially, what sort of data we require? We need, because in this question fc dash and fc prime and f of y is not given, so we have to give a value by ourselves through our experience. So in this type of question, if there is no fc value, fc prime or f of y, now we will give this value. Now what data we require to further proceed of this design is fc prime, we don't know, f of y, b, d, and vector load, wu and mu, moment. This all data we require all of this data. Now we will assume that our f of c prime is equal to 3 ksi. If it's not given in this question, f of y is equal to 60 ksi. B width, this is already given in this our question, is 9 into 18 inches. So we can say that for a section of beam, that has been drawn here, this is the value that we have been already given by the examiner. Now this is 9 inches width, 9 inches width, and this whole height is, now this is height h. I can say that h is equal to 18 inches. So we have b is equal to 9 inches and d is equal to 18 minus 3.5 inches is equal to 14.5. Now what is this 3.5? We are assuming that these are our bars. Usually we provide these tension bars in 2 layers, in 2 rows. So we assume that this distance cover plus half of bar distance is 3.5 inches. So we get our effective distance d, effective depth d, from this point to this point is equal to 14.5 inches. Another thing that we require is d dash. What is actually d dash? D dash is the cover plus half diameter of the compression bars. Now these bars are usually provided at this point. Usually the compression bars are provided in one row. So we have our 4 bars that has been one row of bars in compression has been provided, and the to calculate this d dash is this distance, and it is usually assumed at 2.5 inches. Okay, so we have our d dash is equal to 2.5 inches. Now we will calculate WU. W is a factored load. Okay, this should be provided by the examiner. Now we have dead load of 1.1 k and live load of 0.65 k, and uniformly distributed. It is uniformly distributed excluding its own weight, so we have to calculate its dead load as well. So here remember this value is 1.1 and 0.65. So now here I will further proceed here. Now to calculate this WU, initially I need dead load, self weight. Dead load is equal to 1.1 plus self weight. Now to calculate the self weight, I will make it 150 multiply by, now what is this 150? 150 is, I knew that the density, I need a bit of rough work as well as here, like I make this line so that we can have a bit of rough work here. Now what is this 150? This 150 is density of concrete is equal to 150 pound per cubic feet. Okay, so 150, now this value is in kilo, so we will divide this 150 divided by 1000 to make it as in kilo, multiply by the dimensions we have been given in this problem are 9, b into d we have 14.5. so by making this we get our dead load is equal to 1.27 k per feet. Now we have to calculate our dead load or vector load. So I can say that the vector load is equal to 1.2 times dead load plus 1.6 times live load. That would be equal to, now we can calculate, we know our dead load is this, our live load is 0.65, so we can calculate this. I got 2.56 k per feet. That's my WU. So I can also write this is 2.56. Now I get this 2.56 k into feet. No, k per feet, it should be k per feet. To calculate WMU, I knew this is my span length of 22 feet that has been given in this question. I can mention that span of 22 feet, simply supported reinforced concrete beam with a span of 22 feet. So I can draw this figure like this, and I knew that this is my span, and this is the UDL of 2.56. so I can say that my MU is equal to WU L square by 8. So this gives me answer of about 155.122 k into feet. 155.122 k into feet. K into fit. So I get 155.122. So these are my initials before deciding or before going towards any step. 155.122 K into fit. These are my initials before proceeding to any other step. So now we will continue our next step in the next part of our video.